Welcome back to another video. It's a somewhat tutor, and in this session we're going to be covering the chain rule. So if you're differentiating something that looks something familiar like what we have on the left hand side, which is y equals brackets 2x minus 7 close brackets to the power of 9, where we've got just a single x term, so we haven't got two x terms, what we can use is the chain rule. What the chain rule says is, let's break this down. Let's not only look at the x and y, let's add the letter u. Now you might think that's a little bit more complicated, but let me show you this. It's not. So the chain rule, what does it say? It says the differentiation is equal to dy over du multiplied by du over dx. So please set out your equation just exactly how I'm going to do it, and I'm going to show you why it's going to be a lot easier to follow the rest of the examples. If we have dy over dx is equal to dy over du multiplied by du of dx, can you see if we cancel that through and cancel that through because they're common, you get dy over dx. That's exactly the same as the left hand side. So let me show you an example. What we say is we give the x term, whatever belongs to the x term, the letter u. But in this case, because we've got a bracket, we're going to say all of this is equal to u. Then look at this. So we've got dy over dx is equal to dy over du. That means we must differentiate with respect to u for the y equation. So we say y, in this case, is equal to u to the power of 9. So we've just replaced this bracket with a u. And what we're going to do is just write the differentiate on the right hand side. So just copy the way I do it. So dy over du, and we differentiate this as normal. So imagine this was just x to the power of 9. What do? We bring the power down, which is 9. We write x, but in this case we're differentiating in respect to u. So we just write u, and we take 1 away from the power. So that's 8. That's 9 u to the power of 8. So we need a second term of du over dx. What does that mean? That means we've differentiated u with respect to x. Just exactly what we did. Here we had y, and we differentiated with respect to u. So it's exactly the same. So if you're unsure what these means, always look at the top. Forget the letter d. We begin with u, and we differentiate with respect to x. We've just stated u is equal to this bracket. So we say u is equal to 2x minus 7. Then we go to the right hand side, we say what is the differentiation of u with respect to x, and that's going to be just 2. So now can you see we've got dy over du and du over dx, so we just multiply these two together, and what does that equal? That equals 9 times 2, which is 18 u to the power of 8. We just substitute u back into it, so we've got 18 lots of u, which is 2x minus 7 to the power of 8. And that's the final answer. So hopefully that was simple. What I'm going to do is add a few more examples to help you through this. Hi everyone, I've just noticed my recording did stop on this equation, so for this case let's quickly just go through this one. In this case of y equals to cos x squared, what do we say? Everything associated with the x is equal to u. In this case, imagine there was a brackets here, as you normally have y is equal to cos bracket x. This x squared term is going to be our u. So what do we say? We've got y is equal to cos u. Let's differentiate that as normal, dy over du, and that's equal to negative sine u. Now we've got u is equal to x squared, therefore our dy over dx is equal to 2x. What do? We multiply the two terms on the outside, and that equals to minus 2x sine u. In this case u is x squared, so we just put it in. So here's the final answer. So hopefully that's made sense. If you've enjoyed the video, please leave it a like, please consider subscribing, and I'll see you guys in the next video. Take care.